So now we will resume this. Okay, we have to prove that this 1, 2, and 3 we have to prove for PW belongs to L1 of Z and Z belongs to L2 of Z. For part 1 proof, we have suppose Z belongs to L1 of Z for each theta belongs to minus pi pi this Z star theta cap of theta. How it cap is defined like that summation n belongs to Z star W of n e raised to I n theta. The components of Z star W when it is raised to the cap, we have the summation Z star W of individual components into e raised to I n theta. This is equal to summation n belongs to Z, summation k belongs to Z. We will write the definition for Z star W of n, that is summation k belongs to Z, Z of n minus k into W of k. Then e raised to I n theta, we will split it as e raised to I into n minus k theta, e raised to ik theta, e raised to ik theta and e raised to minus ik theta here will cancel and we will get e raised to I n theta. So by expanding this, this right hand side will converge because 1 minute. For ZW belongs to L1 of Z, we have this right hand side will be less than or equal to this norm Z star cap. 1 minute. Uh, this norm Z star W will be less than or equal to norm W1 Z uh, norm Z square. So we have earlier seen that Z norm Z is same as norm Z cap. We have earlier seen this 1 minute. Yes, here it is. Norm Z square is equal to 1 minute. For Z belongs to L2 of Z, we have this. Uh, Z belongs to L2 of Z. We have norm Z is same as norm cap Z. So here we have this Z star W. For Z belongs to L2 of Z and W belongs to L1 of Z, we have this Z star W belongs to L2 of Z, and this 1 minute. Z star W. So this norm Z star W will be equal to norm Z star W cap whole cap, that will be less than or equal to here norm W, norm 1 W, norm Z square. That will be a finite answer because W belongs to L1 and Z belongs to L2. So this uh, this Z star W cap, that is equal to this summation. So this summation will be less than or equal to infinity, not equal to, less than infinity, will be a finite value because this holds. That is because this right hand side is convergent. This is a convergent double summation. So this convergent double summation can be written as, we can interchange this summation. Here it is n belongs to Z and here it is k belongs to Z. It can be, it is also right to it is not wrong to write that summation k belongs to Z and summation n belongs to Z, this all time. If we for if we expand this summation k belongs to Z, we will get like this. 1 minute. We have this 1 minute. Sorry. Yes. We have this summation k belongs to Z, summation n belongs to Z. This whole quantity will become, we can interchange this summation, no problem, because the right hand side this summation is convergent. So we can for summation k belongs to Z, we will expand like this. For k is equal to 0, we have summation n belongs to Z. This Z of n, W of 0, because W of k here, k is equal to 0 here, W of 0 e raised to I into n theta e raised to I 0 theta. So in this term we can common out w of 0 and e raised to I 0 theta because it is not dependent on the index n. So we will write this as w of 0 e raised to I 0 theta into summation z of n. Summation n belongs to z, z of n. W of 0 is not here. We have common out this, and this e raised to not here. E raised to I n theta will be left. For k is equal to plus, this is summation k belongs to z. We have written one of the index k is equal to 0 plus k is equal to 1. In k is equal to 1 case, this become summation n belongs to z. This 1 minute, z of n minus 1 into w of 1 e raised to I into n minus 1 of theta e raised to I 1 theta. We can also common out here w of 1 and e raised to I 1 theta because it is not dependent on the index n. So w of 1 into e raised to I 1 theta here. So in expanding k is equal to 1 plus k is equal to 2, and in left side also k is equal to minus 1, we can common out this w of 0, that is w of k e raised to I k theta, that is common out here. W of k e raised to e w of k into e raised to I k theta, summation k belongs to z, and this inside this bracket we have summation n belongs to z, z of n minus k e raised to I k n minus k into theta. Okay, fine. Then we will get this this summation can be written as summation k belongs to w of k e raised to I k theta into summation this n by k. We will write this index changes an index n by n minus k to m, and we will write this is, since this is an infinite sum, we will get every integer here if we change also n to m. So we have m belongs to z, z of m, n minus k can be written as z of m, and e raised to n minus k m theta. What is this one? Summation w of k e raised to I k theta into this one. What is this summation w of k e raised to I k theta? This is a w cap of theta. It is defined, and this one, what is this summation? This is z cap of theta. So this z star cap of theta will be z equal to z cap of theta into w cap of theta for z belongs to L1 of z. We have to prove this result for z belongs to L2 of z and w belongs to L1 of z. So this here it is z belongs to L1 of z and w belongs to L1 of z. We will prove it for the z belongs to L2 of z. Uh, as we have to the z cap and z star cap must be defined in L2 sense, and for for this we now define for each positive integer capital N, define a sequence zn by setting z of n is equal to z of n for mod n less than or equal to n, that is minus n less than or equal to n less than or equal to n. For these indexes from minus n to n, we have zn of we have a new sequence zn, that's nth components from minus n to minus capital N to plus capital N. It will be z of n same, and all other components will be 0. Then z of n belongs to L1 of because z, because it is summable. Mod z of zn of m, mod m belongs to z because it has only finite number of terms for each n. For each n we have only finite number of terms, so this is less than infinity and belongs to L1 of z. For zn for each n, L1 of z. So in this we have proved the result for L1 of z. So we have zn star w cap is equal to zn cap w cap, because here we have proved it for L1. So this for each n this is true, we will take the limit in this norm as n tends to infinity on both sides, and we will prove our result. For the left hand side, for limit taking n tends to infinity, we have this sequence zn defined here, n is equal to 1 to infinity, uh, converges to this z in a norm, because for zn we have for finite terms it will be equal to z of n. As n tends to infinity, all its terms of zn will become z of equal to z of n. So as n tends to infinity, zn goes to z. because all components are will be same. So Zn converges to Z in this norm defined Z, um, yes, L1 norm we have this. So that is norm, sorry, L2 norm here it is used because uh, Zn will be element of L2 also. Zn will be element of L2 also because summation, finite summation will be whole square എടുത്തു കഴിഞ്ഞാലും finite sum തന്നെ ആയിരിക്കും നമുക്ക് കിട്ടുക. So this in this so Zn converges to Z in norm 2, that is norm 2 Zn minus Z will be tends to 0 as n tends to infinity. So by lemma 4.34 we have earlier seen that this some one minute, we have this norm Zn star W minus Z star W is equal to norm Zn minus, because a star can be kept inside this bracket. We can expand this bracket because for the definition by star you can easily prove that Zn minus Z all bracket star W is same as Zn star W minus Z star W by the definition of star convolution. So this in the lemma 4.34 we have seen that norm Z star W will be less than or equal to norm Z into norm W1 the norm. So here Zn minus Z star W norm will be less than or equal to norm Zn minus Z norm W1, and since Zn minus Z tends to 0 in 2 norm, we will get the whole, this whole sequence will be as n tends to infinity will be tending to 0. That is uh, this 1 minute. This in by Plancher's formula 4.38 we have norm Z is same as norm Z cap. So uh, taking cap of this element we will have Zn star cap, because cap can be introduced into the inside part of this bracket by the definition of cap. See the definition of cap and you can easily prove that a plus b the whole cap is equal to a cap plus b cap. So the whole cap will be equal to norm Zn star W cap minus Z star W cap. So this cap is same as this one, and this one goes to 0 as n tends to infinity. So this cap also goes to 0 as n tends to infinity. That is Zn star W cap is limiting to Z star W cap. That is the left hand side here. As n tends to infinity, this whole term will goes to Z star W cap. So the left hand side we have proved, that is it goes to Z star W cap. So for the right hand side, as n tends to infinity, for the right hand side we have this definition of W cap of theta mod is equal to modulus of W cap of theta. Definition is summation W of n e raised to I n theta will be less than or equal to this all summation modulus will be less than or equal to individual summation mod by, we have earlier seen as this in the finite case, this is finite case as each n this inequality is satisfied, then as n tends to infinity the limit also satisfies this inequality. So this full mode will be less than or equal to modulus of W of n modulus of e raised to I n theta. Here e raised to n theta, modulus of e raised to I n theta, you know that this is equal to 1. So we will get this like this: summation n belongs to Z mod W of n, that is the summation mod n belongs to W of n, it is norm 1 of W. So using this inequality, norm mod W cap of theta will be less than or equal to norm W1. We will get Zn cap the W cap minus Z cap W cap the norm the whole square. We have in equation 4.38 the not going to 4.38. We will from here also we can write, because Zn cap minus Z cap bracket W cap norm square will be less than or equal to this norm 1 square, this norm W 1 norm W cap, here it is W cap norm 1 square. This 1 minute. 4.38.